Next up, the Mythbusters have a myth on the brain.
Okay, well, I hope you guys have your brains in gear.
Always do.
Good, because for this next myth, you're going to need them. We are testing a myth that is so prevalent that it's just taken for granted that it's fact. Humans only use 10% of their brain.
You hear that everywhere. It's like ingrained in our society.
Definitely, but that doesn't necessarily make it true.
This myth is so pop culture that it even made it to The Simpsons.
Joke if you will, but did you know most people use 10% of their brains? I am now one of them.
But are we really only using a fraction of our brains?
I think we need to come up with the biggest, most challenging brain test, one that will test every single area of the brain.
Well, let's utilize some sort of technology that can monitor brain activity and then maybe come up with like a quiz that could stimulate that activity.
Sounds good, but you know, I think we need some more info. So if you guys want to figure out how we can map the brain for a quiz, I'll find out more about the brain itself, its parts, and how they work.
Cool.
So before they start quizzing, they need a brain expert. And Grant has found just the man, Dr. Manley.
So if we were to go about testing what percentage of your brain you use, what sort of tests could you recommend?
There's a number of tests that one can do to look at brain activity or functional connectivity. One of the earliest ways that we determine to do this is with what's called an EEG, or an electroencephalogram, and this is where we measure the surface electrical activity on the brain. And when you do an EEG, you can see that all parts of the brain have some sort of activity.
I know the brain handles a lot of functions around the body, but what are the various parts and what specifically do they do?
The brain is probably the most complicated organ in the human body, and as you can see here, the brain has many different parts and structures, which we break down typically into the frontal lobes, which are involved in executive functions such as planning and judgment. We have the temporal lobes here that are primarily involved in language here on the left side, and towards the medial part of it are involved in memory. The parietal lobes here help to integrate a lot of the sensory information. The occipital lobe, which is in the back, is how we process all of our visual information and things of that nature.
And that's important to remember for testing this myth. With different areas of the brain responsible for very different functions, they'll need a variety of tests to trigger every single part of Grant's brain, so the EEG can track its activity. Armed with this info, Grant heads to the studio where the brain games can begin.
To test the myth that we only use 10% of our brain, we have this amazing Brain Busters game show set. Now, Grant's going to be hooked up to an EEG and monitored by our specialist, Cynthia Curson.
Will this enhance my innate telepathic abilities?
No. I get to play the host today and present him with all of his challenges.
So now, the first round of Brain Busters. Memory Mania. This tricky test will target his temporal lobe.
Grant, we're going to present you with 10 images of a person and an object. Then we will repeat the images of the people, and you have to name the object that's associated with that person. Are you ready?
I'm ready.
Adam Savage goes with
Orange.
1 right.
By recalling who goes with what,
Gun.
2 right.
Lion.
That's 3 right.
Grant's temporal lobe is triggered,
Tree.
4 right.
and the corresponding brain activity is recorded on the EEG.
Cloud.
6 right.
Wheel.
7 right.
With 1 test down and 1 perfect score, round number 2 is crazy calculation, which should be the ultimate challenge for Grant's parietal lobe.
Are you ready?
I'm ready.
Begin. 12.
13.
To add extra difficulty, the numbers will spin and fade, while an audio track spits out others to distract Grant.
10.
You are correct. The answer is 10. Next question. 12.
2.
You are correct.
Then, the unthinkable happens. Grant gets a math question wrong.
6.
The answer is 7. You fail.
6.
But 1 wrong answer doesn't deter Grant,
5.
Correct.
and he nails the rest of the round.
2. 12. 6.
You are correct. You get 9 out of 10 and advance to the next round.
Grant's brain is certainly getting a workout, but is it a strain on more than 10% of his brain? Stay tuned for the final round of Brain Busters.
My goodness.
And later,
We're going to try the world's biggest tablecloth pull.
now for the final part of the game show made for your mind. Brain Busters. Grant's brain is in the hot seat
6.
to find out if he's using more than 10%.
And we're back for more Brain Buster Challenge. In this challenge, we will be stimulating the frontal lobe. Now, this part of the brain is used in planning, decision-making, risk-taking. So in this next test, Grant will be forced to make a decision in the face of risk.
Grant, right in your face is a 12-inch balloon. You will control its inflation by the button at your fingertips.
This is a risk and reward task.
Are you ready?
I'm ready.
Start to inflate.
The longer Grant inflates the balloon, the more points. However, if the balloon bursts, he'll get zilch.
Okay.
4.4.
4.4.
Inflate all the way.
My goodness. Okay.
9.3.
Wow. That was a crazy big balloon.
With his frontal lobe probed, the final challenge is flash frame.
So the next round, we are going to stimulate the occipital lobe. That is the lower back part of the brain. This is the one that helps you process visual information. Let's see how Grant does this round.
This test may look easy,
Hammock.
but Grant's occipital lobe must work hard to detect the differences.
Greenhouse. Asparagus. Mane on the zebra.
You got 4 out of 5 correct.
And for those of you playing at home, here's what Grant missed.
The clouds actually appear on the horizon.
Got it.
With that, this episode of Brain Busters is over.
So we have tested all 4 lobes of the brain. But now what we need to do is look at the EEG, crunch the data, and find out exactly how well his brain is firing.
The Mythbusters have only one thing on their mind. Do humans use only 10% of their brains? After a tense wait, Grant's brain power results are in.
So we can't wait to find out. How did Grant do through the challenges?
Well, I was happy to see that Grant did very well on his test. He compares pretty closely to normal, and all of the parts of the brain that we thought would be illuminated during the different tasks, for the most part, were.
In fact, for every test, Grant's brain activity is lit up on the EEG just where you'd expect.
We have activity right here in the temporal lobes. There was activity in the left parietal area while he was doing this math task. You can see here that we did pick up some activity in the occipital lobes in the deeper structures.
Grant's brain is working, but how much of it is engaged?
So Cynthia, what's the bottom line? Based on these tests, can you assign a percentage to the amount of my brain that I'm using?
Based on these results, we can see that the right parts of your brain were being activated during the certain tasks, but we can't really make a determination about the percentage of your brain that you were actually utilizing.
The results of the EEG tests showed us that we actually constructed these tasks to excite the right parts of the brain, and in fact, they were excited in the way that we expected. Unfortunately, they were inconclusive in actually giving us a percentage that we could assign.
The EEG focuses on the surface activity of Grant's brain, so it can't provide a conclusive all-over percentage. And inconclusive just doesn't cut it for the Mythbusters.
So we need another brain testing device.
I think I have just the thing. We should go to the MEG. Apparently it can give us the kind of brain mapping we're looking for.
Oh boy, I see more quizzing in our future.
Well, actually, Tori, more quizzing in your future as the team heads to UCSF Biomedical Imaging Lab, where they'll use an MEG to read Tori's mind.
I don't know if I'm ready for this.
Now, the magnetoencephalograph is much more comprehensive than the EEG. Any electrical current is going to produce a magnetic field. The MEG uses extremely sensitive superconducting sensors to measure the field that the brain's electrical current generates.
It's a sensitive machine that can detect even the tiniest brainwaves. And in the capable hands of the UCSF brainiacs,
You guys aren't going to erase my memories, are you?
Don't worry.
Tori is carefully hooked up for testing.
Help me get out of here.
So we're going to put this microphone up by your mouth so we can record what you're saying.
You're going to leave me in here?
Bye.
Bye. Should we start at defrost and work our way up?
And now comes the hard part, a series of 4 tests to put Tori's brain to work and find out if he's using more than the mythical 10%.
All right, please start holding still.
Like the EEG, we're going to start by firing up the temporal lobe. Now, this is the one associated with memory and auditory stimulation.
Okay, Leighton, so how does this test work?
So I've trained Tori on these word pairs, and what he's going to do is he's going to hear one of the words, and he's going to speak back the word that he's been trained on that's associated with the first word.
Basket.
Tori.
Book.
Adam.
Coffee.
Grant.
Tori completes test 1 with flying colors, and then it's on to the occipital lobe test with some familiar faces.
I feel like I'm in a Kubrick film right now.
Okay, Tori, here's what you're going to do. You're going to be looking at the screen, and there are going to be faces appearing on the screen.
Okay.
And the faces are either going to be ones that are familiar to you, like Carrie there. If you see a familiar one, you press the button with your right hand.
Okay.
If it's an unfamiliar face, one you've never seen before, like that person right there, you're going to press the left button.
Okay.
And that's it.
Hey, who's that guy? Now, the occipital test, it wasn't that hard, but it was designed to stimulate the part of my brain that visually recognizes things that I already know.
Yeah, I just saw him push a button there. That's cool.
Test number 3 is a simple math task to stimulate Tori's parietal lobe.
All right, so what's this test all about?
There's going to be a pair of numbers flashing on the screen, and the numbers can be either the same or different. And if the numbers are the same, he's going to press the left button. If they're different, he's going to press the right button.
As the numbers flash, Tori does his best to press the right buttons, but it seems the tension is getting to him inside the MEG.
Oh, try not to grit your teeth, please.
All right.
For the frontal lobe quiz, the team uses a test which seems like a simple enough combination of text and color.
What happens is a word appears on the screen, and the word is a color, either yellow or blue. And the color of the word itself can be either the same color as the word or a different color. And when the two are incongruent, it creates cognitive conflict, and that really drives activity in the frontal lobe.
I like that one. That's cool.
It's cool, but deceptively difficult. And with all the tests complete, Tori's head is completely checked.
Hey, good job, man.
Who are you people? What year is it? All right, so tell me, am I using more than 10% of my brain?
We'll know in a couple of days. We'll have to crank on the data.
But preliminary results show that you're missing part of that frontal lobe where it tells you not to jump over red wagons with bicycles.
Can we wipe that memory from my brain?
Did you know most people use 10% of their brains?
According to The Simpsons, this is fact.
He was all over the place.
But the Mythbusters are putting that to the test.
Well, this has been terrific. Let's do it again sometime.
And Tori's MEG results are in.
We're back at UCSF to get the results for Tori's MEG. This is going to tell us if our myth is confirmed. It's a really big moment for us.
Yep, so it's over to the neurologists to reveal the final percentages.
So we've got the results from the MEG. How's the myth looking?
Very interesting. I think that there's an element of truth to this myth. If you look at a 100 millisecond time scale and you're doing one thing.
Basket.
Tori.
We see about 10% of the brain active.
But that's just 1/10 of a second. What's the percentage of the brain activity during the entire challenge?
We found that the total overall brain activation was about 35%.
35%.
So the myth is busted.
Totally busted.
So the essence of the myth, I really believe, is that you're only using 10% all the time. So for that, you're pretty much saying it's busted. But what's interesting is just that 1/10 of a second. There's a little bit of plausibility there. That's really cool.
Even individually, Tori's lobes were still firing at more than 10%. So the myth is busted. But that's given our brain busters a brain wave. And they can't leave it there.
Mythbusters.
So after all of our tests, we have proven that we do use more than 10% of our brain. But now it's time to go deeper to find out exactly how much or how little of our brain we use. So we're here at UCSF to get an fMRI, a functional magnetic resonance image. This should be interesting.
Once again, Lab Rat Tori is ready for testing. But instead of quizzes, this time they're doing things slightly differently.
All right. Engage.
You're such a nerd.
Newsflash. So the first test that Tori's going to take in the fMRI is going to be the bare minimum of activity. He's going to be at rest with his eyes closed.
Okay, Tori, what I need you to do is try to stay still and stay awake for the next 8 minutes. Here we go.
And that way we can see, when you're doing absolutely nothing, how much of your brain you're actually using.
That's insane.
So that's what he looks like as a zombie.
Even at rest, it seems that Tori's brain is still very active.
That's so cool.
And eventually, after 8 minutes, it's time for test 2.
We're going to try to have Tori fire up every lobe of the brain and the cerebellum all at once. Now, to do that, we're going to have him tell a story out loud. The story is going to involve trauma, recollection, order of events, all sorts of things that we can see all of the brain firing at once.
Okay, Tori, we're going to do the storytelling part of the experiment. We're going to begin.
So one day, we were out riding bikes.
Interestingly, Tori's traumatic story involves an unfortunate bike accident.
Gosh, pretty scary.
He's lighting up like a Christmas tree there.
Yeah.
What's going on?
Well, as he's telling the story, there's activity in a lot of brain regions. So you can see these parts of the frontal lobe in either hemisphere active as he's telling the story. Now he's taking a break and you can see the activity go down. And when he hears himself tell the story, you can see activity in the auditory cortex and the temporal lobe light up.
That's great.
And with Tori's story over, he's ejected from the test tube.
The interesting thing about our test today is that at rest, your brain is using so much more than I actually expected.
You're like a lab rat. Yeah.
I mean, I knew that when you were going to tell a traumatic story or you're doing something interesting that you're going to have a lot of things firing. But when you're just sitting there doing nothing, you're already looking like you're using more than 10%.
Next.
Tablecloth pull! 600 feet of rope! 100 miles an hour! Jamie, go!
They're gonna fry my brain.
The Mythbusters have been picking Tori's brain to find out just what it can do. And now the results are in.
So, Leighton, from the results that you were looking at, overall total percentage, how much was Tori using at resting point?
So when we're looking at the brain at rest, if we look at 3 major networks in the brain, the visual network, the auditory network, the sensory motor network, if you put those 3 networks together, even at rest when he's not doing anything at all, that accounts for about 15% of total brain activity.
The scans for Tori at rest clearly show that even though his body is inactive, his brain certainly isn't.
All right, so this is the test where I'm trying to recall a story and try to use as many lobes as possible. What did I come up with?
When you're telling the story, we see activity in the frontal lobe, in the temporal lobe, in the visual lobe, and also in the limbic lobe as you're experiencing the emotional content of the story. And there, across the brain, we see about 30% of the total brain volume active.
That's the most brain power for any individual test across all the different scans. With all of Tori's lobes engaged, his brain maxed out at a huge 30%.